All right, so let's talk about graphing exponential functions. First of all, an exponential function is where x is in the exponent spot, okay? Our parent function is this y equals b to the x. A is one of our values that changes it. A can't be 0, obviously, because 0 times anything is 0, so that makes it not a function. B has to be greater than 0, and it can't be 1, because 1 to any power is always 1, so that doesn't give you a function either. And then if it was 0, obviously it would all still be 0. So it's got to be positive. It could be negative, but that would just mean that the A was negative. So technically B is always positive, okay? So here are just some examples of exponential functions. When we go to graph it, you can do it in a couple of ways. We're going to first start with a table of values so that you can see what the shape is like, right? Because we've never graphed this before. So if I just have some values for x, like -2, -1, 0, 1, and 2, you just make up your values for x to put in a table. If I plug in -2, that's 3 to the -2 power, which gives us 1 over 9. So y is 1 over 9. 3 to the -1st power is going to give us 1 over 3. Because remember, guys, anytime you have a negative exponent, it just brings it to the bottom, okay? Creates a fraction. And then 3 to the 0 power, anything to the 0 power is always 1. And then 3 to the 1st is 3, and 3 squared is 9. So there's our table of values. We're going to come over here and we're going to graph them. So I've got 2, 9, so 1, 2, and then all the way up to 9, and put our dot. 1, 3, 0, 1, -1, 1/3. So you can just guesstimate here, go about 1/3 of the way up. And then -2 and 1/9, that's going to be really close to 0 right here, right? So we're just going to draw our dot close. So as you can see in our dots, it does give us this little ramp, is what we call that exponential function. It's either a ramp up or a ramp down, and it's kind of just an L curve there. This is a growth function because 3 is greater than 1. Anytime it's greater than 1, it's a growth, and it's always going to go up exponentially, right? If it was a decay, it would come down, and I'll show you one of those in a second. But this is how you graph using a table. You just plug in some values and fill it in, right? So that gives you a good graph. Now, you don't want to make a table of values every time because it's kind of time consuming, right? So we're going to use our key features of our graph here, which is the intercepts, and then just an extra point to tell us whether it's going to go up or down. And we can always use 1 because that's the easiest, right? So first of all, let's graph our intercepts here. So if I want to graph my y-intercept, that means I make x equal to 0. So that's just going to be y equals 2 to the 0, which is always 1. So fun fact here, an exponential function, as long as it hasn't been shifted up or down, right, our parent functions will always have an intercept of 1 because anything to the 0 power is always 1. So that's a great point to start at whenever you're graphing. This is kind of like our vertex on a parabola or whatever. This is that point we're going to move around. The x-intercept now, if I make y 0, this is what he was talking about in Edgenuity quite a bit. If I make y 0, this says 0 equals 2 to the x. Well, can I raise 2 to a power, any number up here, and get 0? That's big negative, guys. If I plug in a negative number here for x, it's just going to give me a smaller and smaller fraction, okay, like 1 over 32 or 1 over a bajillion. It's going to keep getting smaller and smaller and smaller, and it will never get to 0. And if my number gets bigger, it's just going to get larger and larger, right? So that's what creates that curve. And your x-intercept doesn't actually exist because it will never cross the x-axis, right? So we actually get what is called that asymptote. And I can't remember if we got to asymptotes or not before we left, but it gives you what's called an asymptote at that line right there. That x-axis is your asymptote. So at y equals 0, sorry, it can't cross, okay? So then I'm just going to plug in 1 to give me an extra point. So 2 to the 1st power is 2. So that gives me the point 1, 2. So I can graph this at a point right here, and it tells me that my curve is going to be a growth curve. I know it's going to approach the x-axis, so I can get real close to it, and then just sketch my curve going up. So that's just a quick sketch of a curve, okay? Where's your y-intercept, and then is it a growth or a decay? All right, so this one is a decay. How do I know that? Well, I know that because my base right here is 1/2, okay? It's less than 1. So again, I can use my intercepts I know that my y-intercept is always going to be 0, 1 because this is a parent function and I haven't shifted it. And my x-intercept I know doesn't exist because I'm going to get that asymptote at that line y equals 0. And so when I plug in 1, I'm just going to get 1/2. So I've got my points right here. I've got the intercept at 1. The point 1, 1/2 tells me that this is now going to go down. This is a decay curve. So I'm just going to sketch my curve, let it approach the x-axis, not cross it, and there you go. It's a little sketch, okay?